All right, good morning, Transitional Algebra at CCTI. Mr. Pashar here once again. I hope everybody is doing well and healthy and staying safe. You're probably tired of hearing that. I am certainly tired of hearing, you gotta stay home, you gotta stay safe, but it's not my decision. Anyway, as you could tell, I got a little bit of a suntan trying to get outside in between the garden and do stuff like that, cut the grass. I planted peppers and tomato plants. I planted a bunch of flowers. Yesterday I rung up my credit card by buying tons of flowers and vegetables and whatnot. But it's nice to be able to get outside. And I hope you guys have had an opportunity to get outside and do some things. We are winding down the year. You know, isn't it something? When we left school it was March, and now we're in the middle towards the end of May, and we are almost done. And I just want to take this time also to say how proud I am of everybody. Overall, generally, everybody's been doing the work and handing it in on time. Again, I understand this is not easy. Math is one of those subjects that when you have to do it online, it's very difficult. Take it from me. I'm still taking classes in mathematics. I'm doing them online, of course, and it's not the easiest thing. When you have a problem, you got to try to reach out to the professor, email back and forth, telephone call. It's not easy, you know, especially when you're doing graduate mathematics stuff. So I understand where you guys are coming from. But today, we're going to step back a little bit and look at a topic that you have some familiarity with, exponents and radicals. And then we're going to kind of put them together and see how they're related. So we're going to look at, this is lesson 8.4, and this is radical notation. For nth roots. So what are we learning here? What we're going to learn here is how exponents and radicals go hand in hand. So for example, if we look at the square root of 4, right? The principal square root of 4 is 2. We know that because we know that 2 squared is 4. At one time, I mentioned to you guys that the square root of 4 could be represented as an exponent. That radical, we could erase it and give it an exponent instead. And whenever we deal with radicals, we have fractional powers. So we could write the square root of 4 as 4 to the 1/2 power. It's like using your microwave, you know, power level 5, that would be the half power, right? Power level 9, for example, right? All those. So we have 4 to the 1/2 power. Now, watch where this comes into play, this 1/2. If you don't believe me, if you think I'm pulling a fast one on you and you're saying, Mr. Pashar, where the hell are you getting the 1/2 from? Let's investigate. So start off again with the square root of 4. Well, we know that we can write 4 as 2 squared. That's what answers the question of square root of 4. So this is the square root of 2 squared. So in other words, 2 squared raised to what power is going to give me 2? Because we know damn well the square root of 4 is 2, right? So the question is, what is this question mark going to be? 2 squared to what power is going to give me just 2? Well, it has to be 2 times what number will essentially give you a 1 or clear that exponent. And that answer is 1/2. So that's how we get the 1/2 power, right? We could say the same thing for, how about this, the cube root of 8. We know the cube root of 8 is 2 because 2 cubed, or 2 times 2 times 2, gives you 8, right? So what does this mean as a fractional exponent? This is 8 to the 1/3 power, and that's still 2, right? But let's go ahead once again and investigate that idea. It's the fact that, well, if you have the cube root of 8, right? What that means is you have the cube root of 2 cubed, which is 2 to the 3rd power raised to the 1/3, and that gives you the 2. So you see, if you have a cube root, that means you have the 1/3 power, right? It's like that song, I got the power, right? No, that's Probably showing my age a little bit, right? I got the power. All right, whatever. So that's how that works. So we could continue this and keep looking at other types of radicals with this, and you'll see in general the fact that we have the following. So let's clear some of this out of here. And by the way, this carries over into the algebra part of this. So it works obviously for the concrete real numbers, but also works for the algebra size we're going to see. So in general, what do we have? So in general, for all real x, right? Of course, we're going to have restrictions because, for example, you can't have negative numbers under the square root, for example. But for all real x, we have the following ideas. We have that the square root of x means we have x to the 1/2 power. Again, provided that x is greater than or equal to 0, we have to assume that, right? If we have the cube root of x, that's x to the 1/3 power. We don't need a restriction there because, as you learned earlier in the year, things that have an odd index don't need to worry about negative stuff. But once again, when we turn to something like the 4th root of x, that's x to the 1/4 power, provided that x is greater than or equal to 0. Once again, we cannot have that idea of having a negative number. That involves the absolute value, which we talked about before. So that brings us to a theorem. And as you know, theorems are things that we could prove. We won't prove this one here. But the theorem says for any non-negative x, so for any x greater than or equal to 0, we have the following. The nth root of x is equal to x to the 1/n power. And that's a theorem. And that's important because this thing will help us to simplify radicals in terms of exponents that are ugly, maybe necessarily we don't want to have to solve by trying to break a radical up. Okay? So again, there's a lot of examples in the lecture notes. Make sure you go. Let's see. I don't know who that was. We'll have to figure that out later. And now another consequence that we have here is this. We have, if we have the nth root of x to the m, so this is another theorem. If we have the nth root of x to the m, this is important. We're going to show you how you can rewrite this thing. So we could write it this way. We say x to the m over n. So essentially, the m is on top of the fraction. The number that is in the nth root, that goes on the bottom of the fraction. And you can also write it this way if you wish. This is a way that sometimes your book may write it like this. The nth root of root x to the m power. This is the easiest, I think, but you can also write it this way if you wish. And this helps you with your calculations. Now your calculator can handle these different roots, but it's easier to write them as fractional exponents. For example, if you wanted to figure out what the 4th root of 2186 is, you could type this in your calculator as 2186 raised to the 1/4 power. That makes this easier to compute than trying to use the 4th root. Okay, excuse me for one moment. I'm waiting for a Tractor Supply. I'm getting a grill delivered to my house. Okay, in any case, let's say we wanted to simplify some things like this. If we have the 3rd root of x to the 12th. So if you have the 3rd root of x to the 12th, we use that theorem that we had on the board. We can rewrite this as x to the 12 over 3 power. See, the exponent's on top, and the root here is on the bottom. And that simplifies to x to the 4th, because 12 divided by 3 is 4. Another way you could write it, if you're starting over with this, is we could write this as x to the 12th raised to the 1/3, which would still give you the same result of x to the 4th power, but I think it's a little more work. So I think it's a little bit easier to do it this way. Here's another example. Say we have the square root of x to the 20th. Earlier in the year, we looked at how we could do this by breaking this up in pairs of 2 x's at a time. But we could also do this quickly using an exponent. So I could write this as x to the 20th over 2, because this is a square root, so there's an indivisible 2. So this would be x to the 10th, just like that. Now, how else can you write it? Well, if we start off with the square root of x to the 20th again, we can write that as x to the 20th raised to the 1/2, and that would still give us x to the 10th power. So just like Burger King says, have it your way, either of those will obviously work. It's just how you like to interpret the meaning of the radical. Here's another one, for example. How about if we have the 3rd root of x to the 21st power? The 3rd root of x to the 21st power. So we can write this as x to the 21 over 3 power, which means we have x to the 7th power. See how easy that is? It's easier to rewrite the radical in terms of a fractional exponent than trying to go ahead and mess around with this, right? You'd have to break this up into pairs of 3s. Now, how else can you write this thing? Well, we could call this x to the 21st raised to the 1/3 power, which still gives us x to the 7th, just an extra step. But again, some people like to see that in that fashion. Okay? Now let's look at one more. How about we have the 5th root of, let's say, x to the, let's say, 31st. Well, this would be x to the 31 over 5 power, and guess what? That's all you could do there, because there's nothing more you could reduce. If you're doing it the longer way, this would be x to the 31st raised up to the 1/5 power, which would be x to the 31 over 5 through the simple multiplication of 35 times 1/5. And pretty much that's all there is to this. There's really not much more you need to know at this point, just to be able to rewrite the radicals, but I'm hoping you can see it's much easier to rewrite the radicals using these fractional exponents instead of trying to break the radical down the old-fashioned way. So with that being said, this is a great place to stop. If you have any questions, again, feel free to call me or email between 11 and 1, any day of the week. And if you need a specific appointment, just call me, let me know. I could help you out at night if you really need the help. So once again, I hope everybody is healthy and well. I hope that this video will help you to do your homework. And until next time, please stay safe and enjoy. Take care.